Welcome to Across the Globe. Today we will learn about RStudio Interface Overview. RStudio is an IDE tailored for R programming, allowing users to efficiently write, run, and troubleshoot code. Offering a rich set of features like code completion and debugging tools, it simplifies the development process. This streamlined interface boosts productivity by providing a seamless environment for R-related tasks, increasing efficiency and enhancing the coding experience. An example scenario could be a data scientist using RStudio to analyze a dataset and create visualizations for a research project. RStudio is a comprehensive integrated development environment used for R programming. It is structured into 4 primary panels: console, source, environment, and files, plots, packages/help. The console panel is where you can enter R commands interactively and view the output in real time. It serves as the immediate interface for executing R code. The source panel allows you to create and edit R scripts efficiently. It provides a dedicated space to write, modify, and organize your R code for easier management. The environment panel displays the current R workspace, showcasing objects, data frames, and installed packages. It enables you to monitor the variables and datasets currently in use. The files, plots, packages, help panel offers multiple functionalities. Here, you can navigate through your file system, manage plots, handle packages for additional functionalities, and access help documentation for R functions and packages. For instance, when working on a data analysis project, you can utilize the source panel to craft your data processing script while readily observing the output in the console panel. Simultaneously, the environment panel provides a glance at the variables and data structures being manipulated. Finally, the Files, Plots, Packages help panel facilitates file management, visualization, package management, and documentation access to enhance the overall programming experience. To execute R code in RStudio, you can use the console by typing commands and hitting Enter. Alternatively, you can run R scripts by selecting the script in the source panel and clicking the Run button. For instance, to compute the mean of a set of numbers in R, you can define the numbers in a variable, e.g., numbers C1, 2, 3, 4, 5, and then calculate the mean by invoking the mean function with the variable as an argument, mean numbers. RStudio allows for efficient debugging of R code by offering tools like setting breakpoints and stepping through code. To set a breakpoint, simply click on the left margin of a line in the source panel, marking where you want the code execution to pause. Subsequently, run your code in debug mode by clicking the Debug button. For instance, consider debugging a function where breakpoints are inserted within the function's body to inspect variable values and step through the code execution process. This approach aids in identifying and rectifying errors or unexpected behavior in the code, ensuring optimal functionality. RStudio offers a Packages panel for efficient management of R packages. Through this panel, users can undertake operations like installing, updating, and removing packages. Additionally, packages can be loaded and unloaded to access their functionality within R code. For example, by utilizing commands such as install.packages ggplot2 and library ggplot2, users can seamlessly install and load the ggplot2 package for data visualization tasks. RStudio is like a toolbox for a carpenter, providing all the necessary tools and materials needed to build a project. The console in RStudio is like a workbench where you can experiment with different tools and materials before starting your project. The source editor in RStudio is like a blueprint where you can plan out your project and write out your code. The environment in RStudio is like a storage shed where you can keep track of all the variables and datasets you are using for your project. The plots and help panes in RStudio are like an instruction manual, providing visual representations of your data and tips on how to use different functions. By using the different tools and features in RStudio, you can effectively build and execute your program just like a carpenter uses their tools to build a project. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. go to our website across the globe, www.atg.world. In this code snippet, we are using a carpenter's toolbox analogy to explain the RStudio Interface overview. We start by creating a variable wood length in the console workbench to represent a piece of wood with a length of 10 units. We then check the value of this variable in the console. Next, we define a function cutWood in the source editor, Blueprint, that takes the length of the wood and the number of cuts as inputs, calculates the length of each cut piece, and returns it. We call the cutWood function with the wood length variable and 2 cuts, displaying the result in the console. The cut pieces are stored in the environment storage shed using the variable cutWood pieces. We visualize the cut pieces using the plot function in the plots pane instruction manual to get a graphical representation of the cut pieces. Additionally, we access help documentation for the plot function in the help pane instruction manual to understand its usage and parameters better. Overall, this code snippet showcases how the different components of the RStudio interface, console, source editor, environment, plots pane, and help pane, can be likened to a carpenter's toolbox, helping users efficiently work on and execute their programming projects. An industrial example where RStudio's interface can be beneficial is in the analysis of production line optimization for a manufacturing plant. The console in RStudio can be used to input and manipulate data related to production metrics, such as output rates and downtime. By utilizing functions written in the source editor, like algorithms to calculate optimal production speeds or identify bottlenecks, plant managers can make data-driven decisions to improve efficiency and throughput. Visualizing the results in the plots pane can provide a clear overview of how changes in the production line impact overall output, aiding in decision-making processes. In this scenario, RStudio serves as a valuable tool for analyzing and optimizing production processes in real time. In the context of academic research, RStudio's interface can be applied to analyze and visualize data collected from scientific experiments. Researchers can utilize the console to input experimental data and run statistical analyses to draw conclusions. By writing custom functions in the source editor, like algorithms for data processing or hypothesis testing, researchers can automate and standardize their analytical workflows. The environment in RStudio acts as a virtual lab notebook, storing variables and datasets for easy access and reproducibility. The plots pane allows researchers to create visual representations of their data, aiding in the interpretation and communication of research findings. In the field of academia, RStudio's interface provides a comprehensive platform for conducting data analyses and generating insights from research data. Across the globe, industries and academic fields leverage RStudio's interface to streamline data analysis processes, enhance decision-making, and drive innovation. The seamless integration of coding, visualization, and documentation features within RStudio empowers users to efficiently work on diverse projects, from optimizing manufacturing processes to advancing scientific research. By harnessing the power of RStudio's interface, professionals can unlock the full potential of their data and transform complex information into actionable insights, ultimately driving progress and success in their respective fields. Keep learning, stay curious, and I'll catch you in the next video.